Right now, you are looking at a screen. Light is hitting your retinas. Your brain is converting that light into shapes, colors, and words. You trust this process. You have trusted it every second of every day since you opened your eyes for the first time. You assume that what you see is what is there. Tonight we are going to take that assumption apart, piece by piece, layer by layer, sense by sense. We will start with something simple, the color of the objects around you. Then we will move deeper, into sound, into touch, into the structure of your own body, into the basic coordinates of space and time. At each level, we will meet a scientist who discovered that the layer you trusted is not real. And at the very bottom, we will find a mathematical theorem that puts a number on how much of reality you are actually seeing. That number is 0. Not approximately 0, not close to 0, exactly 0. Let us start with what you see. In 1672, Isaac Newton took a glass prism and placed it in a beam of sunlight. The white light entered the prism and came out the other side split into a band of colors: red, orange, yellow, green, blue, violet. It looked like the prism was adding color to the light. So Newton ran a second test. He took the red beam and passed it through a second prism. If the prism was creating the color, the second prism should change it again. It did not. The red beam came through unchanged. The prism was not adding anything. It was separating what was already mixed together. White light is a bundle of wavelengths. Each wavelength is a specific frequency of electromagnetic radiation, and none of those wavelengths are colored. A wavelength of 700 nanometers is not red. It is an oscillation of an electromagnetic field at a specific rate. There is no redness in it. The color appears later. When that wavelength hits your retina, specialized cells called cones absorb the energy and fire an electrical signal to the brain. The brain receives the signal and assigns it a label. That label is red. So red is not out there. Red is a tag your brain attaches to a specific frequency. The sunset you watched last summer was not red and orange. It was emitting wavelengths, and your nervous system was painting them with sensations that exist nowhere outside your skull. Newton proved this 350 years ago. Light carries no color. Color is your brain's response to a frequency. A translation, not a transmission. And any translation has limits. The question is how much of the original signal your particular translator can handle, because the electromagnetic spectrum is vast, and your eyes cover almost none of it. The electromagnetic spectrum stretches from gamma rays with wavelengths smaller than an atom to radio waves longer than a football field. Visible light is one narrow band on that spectrum, and your ability to see that band depends on hardware. In the early 1800s, Thomas Young figured out that human color vision relies on 3 types of receptor cells in the retina. We now call them cones. One type responds to short wavelengths, one to medium, one to long. Every color you have ever seen is your brain mixing signals from these 3 channels. 3. That is your entire apparatus for sampling the electromagnetic universe. A mantis shrimp has 16 types of photoreceptor cells. It detects ultraviolet light, polarized light, and wavelength distinctions so fine that no human instrument can fully map its visual experience. You and a mantis shrimp can sit side by side in the same ocean looking at the same coral reef. You will see one world. It will see another, not a slightly different version. A fundamentally different place with colors that do not exist in your experience, because your hardware does not have the channels to decode them. Your visible range runs from about 380 to 700 nanometers. That is roughly 0.0035% of the full electromagnetic spectrum, not a window, a keyhole, a slit so narrow that 99.99% of the electromagnetic information in any room you have ever entered was completely invisible to you. And you could not notice the absence because you cannot miss a channel you never had. but set the width of the keyhole aside. Narrow or not, at least the slice you do get should be reliable. Your brain receives a wavelength, tags it with a color. That process should be consistent. The same input should produce the same output every time. It does not. A neuroscientist named Bo Lotto at University College London demonstrated why. He showed subjects a flat surface covered in colored tiles. Two specific tiles on that surface were reflecting the exact same wavelength of light. Physically identical. A spectrometer confirmed they were the same, but the subjects saw them as completely different colors. One looked brown, the other looked orange. The difference was context. The surrounding tiles were different, and the brain was not simply reading the wavelength and tagging it. It was interpreting the wavelength relative to everything around it. It was adjusting the output based on shadows, light sources, and assumptions about the scene. Identical input, different result. And this is not a quirk of the experiment. This is the default mode. Your brain does this every second you are awake. When you look at a white piece of paper under yellow lamplight, the wavelengths reaching your retina are yellow, but you see white. Your brain subtracted the lamp color and showed you what it decided the paper should look like. It overrode the incoming data with its own judgment and presented the result as if it were a direct observation. Lotto proved that color is not even a stable translation. It is a real-time negotiation between the signal and the brain's model of the environment. The brain is not a receiver. It is an editor. It decides what color you should see and then shows you the decision instead of the data. You see the opinion, not the wavelength. And there is no way to access the raw feed, because the editor is the only pathway you have. But you could argue that the editor is at least reacting to something. The wavelength is still there. The input is still real. The brain adjusts it, interprets it, maybe distorts it, but it is working from actual data. There is still a wavelength out there, and the brain is still responding to it. Except in 1959, somebody proved that even that is not required. Two channels of light, red and white, no other color in the system. And somehow, the audience saw full color. Edwin Land, the founder of Polaroid, demonstrated this in the 1950s with an experiment that should have changed everything. He took two black and white photographs of the same scene, shot through different filters. Then he projected them on top of each other. One projector had a red filter, the other had no filter at all, just white light. Two channels, red and white. No green anywhere in the system, no blue, no yellow. By the physics of color mixing, the audience should have seen a washed out pinkish image. Instead, they saw full color. Greens, blues, yellows, skin tones. A spectrometer confirmed no green wavelength was being projected. No blue. The light hitting the retinas contained two signals, and the brain constructed an entire color palette from the relationship between them. Colors with zero correspondence to any wavelength on the screen. Land proved the brain does not need the data to produce the experience. When the input is incomplete, the brain fills the gaps with colors it invents. Not estimates, not approximations, fabrications. This is where the word filter stops being useful. A filter reduces a signal. What Land demonstrated is generation. Your visual system is not a camera capturing a dim version of reality. It is a projector running a full-color movie on the inside of your skull. The signal from your eyes is a suggestion. The brain takes it, discards what it does not like, adds what it thinks is missing, and screens the final cut as fact. Color is not a property of light, not a property of objects, not a stable response to wavelengths. Color is a hallucination your brain runs by default every waking second. And you never caught it because you have never had access to anything but the movie. So color is gone, not dimmed, not filtered, fabricated from scratch, but you can hear things right now. A voice, a hum, background noise, sound feels different. Something vibrates, the air moves, your ear picks it up. That is not interpretation. That is mechanics, except it is not. Something vibrates. A vocal cord, a speaker cone, a branch snapping. That vibration pushes the air molecules next to it. Those molecules push the next ones. A compression wave moves through the air at 343 meters per second and reaches your ear. The eardrum vibrates. The vibration travels through the middle ear into the cochlea, a fluid-filled spiral the size of a pea. Inside, microscopic hair cells bend. Each one is tuned to a specific frequency. When it bends, it fires an electrical signal to the brain. That is the mechanism. Georg von Békésy won the Nobel Prize in 1961 for mapping it. And the critical detail is where sound begins. Not in the air, not in the ear, in the brain. Everything before the brain is pressure. Molecules colliding with molecules. A 440 Hz wave is not the note A, it is air pulsing 440 times per second. The note A is what your brain creates when the corresponding electrical signal arrives. There is no pitch in the air, no melody, no voice. There are compression waves, and your brain converts some of them into an experience called sound and discards the rest entirely. Your cochlea detects frequencies between roughly 20 and 20,000 Hz. That is your window. Below 20, the waves still exist. Above 20,000, the waves still exist. You simply have no receptor for them. The world outside your skull is silent in the most literal sense. There is no music out there, no laughter, no thunder. There are pressure variations, and your brain turns a thin band of them into a soundtrack. The rest might as well not exist. So now we have two senses down. Color is fabricated from wavelengths. Sound is fabricated from pressure. Both are constructions that exist only inside the brain, but touch still feels like solid ground. You can doubt an image and you can doubt a noise, but the table under your hand pushes back. That resistance is not a translation. That is force meeting force, atoms against atoms, physical contact, the most basic interaction in the universe. And it does not happen. Every atom in your hand is surrounded by a cloud of electrons. Every atom in the table has its own cloud. Electrons carry negative charge. Negative repels negative. When your hand approaches the surface, the two clouds push against each other with electromagnetic force. They resist. They slow your hand down. They stop it. They create a sensation of solidity. But they never meet. There is a gap. Richard Feynman described this with a clarity that still holds. At the atomic level, contact does not happen. The distance between your skin and the table is roughly 1 angstrom, 1/10,000,000th of a meter. Tiny, but not zero. And this is not a technicality. The electromagnetic force that holds you apart is one of the 4 fundamental interactions in the universe. It is the same force that holds atoms together, that gives matter its structure. It means that solidity itself is an interpretation. Your brain receives a signal that says the electron clouds are resisting, and translates that resistance into a feeling of firmness, texture, shape. But the firmness is not in the table. The texture is not in the wood. Those qualities are constructed from electromagnetic data the same way color is constructed from wavelengths, and sound from pressure. Every handshake you have ever received, every doorknob you have ever turned, the floor under your feet right now. In every case, your atoms hovered above the surface on a thin cushion of repulsion, and never once crossed the gap. You have not touched a single object since the day you were born. Your brain took electromagnetic resistance, translated it into pressure and texture and warmth, and called it touch. It is not touch. It is the third channel running the same trick as the first two. A signal converted into a sensation by a system that never shows you the raw data. 3 senses down, 3 fabrications confirmed. The pattern is clear. But at least your brain knows the shape of the thing it is lying to. It knows where your hand ends and the table begins. It knows the boundaries of the body it built these illusions for. Does it? Vilayanur Ramachandran at UC San Diego studied patients who had lost a limb. The arm was gone, surgically removed, but the patients could feel it. Not a memory, not a vague sense, actual physical sensation. The missing hand would itch. The missing fingers would clench into a fist so tight it caused real pain. One patient described his phantom arm reaching out for a cup on a table. His stump did not move. His brain insisted the hand was there, moving, gripping, touching the ceramic. Ramachandran proved that the brain does not build your body image from your actual body. It builds it from an internal map. When the territory changes, the map does not update. The limb is gone, but the map still has it drawn in. Your brain keeps generating sensation for a region that no longer exists. The ghost is in the wiring. And the wiring does not just lag behind reality, it can be rewritten. In 1998, researchers placed a rubber hand on a table in front of a subject and hid the real hand behind a screen. They stroked both hands with a brush at the same time. After roughly 120 seconds, the subject began to feel the brush on the rubber hand. When the experimenters stabbed the fake with a needle, the subject flinched and yanked the real hand away. Heart rate spiked. Sweat glands fired. 120 seconds. A rubber glove and a paintbrush. That is all it took for the brain to reassign ownership of a body part to a piece of plastic and defend it like flesh. The boundary between you and the world is not a physical fact. It is an editorial decision made by a system that can be overwritten with props from a dollar store in 2 minutes flat. So the brain fabricates color. It fabricates sound, it fabricates touch. And now it fabricates the body itself. The thing that is supposedly doing the perceiving. 4 channels, 4 constructions. But if the question is no longer about accuracy, if the brain is building everything from scratch, then there is one more test. The most brutal one, pain. If the brain can generate color without light and touch without contact, can it generate suffering without cause? In 1896, a physician named Torsten Thunberg arranged metal tubes in alternating rows. One row carried warm water at 40 degrees Celsius. The next carried cool water at 20 degrees. Neither temperature is painful on its own. Warm is pleasant, cool is pleasant. But when a subject placed their forearm across both rows at the same time, they felt a searing burn, intense enough to pull away, intense enough to trigger a stress response. There was no heat source capable of burning skin, no injury, no tissue damage. The brain received 2 harmless temperature signals, misinterpreted the combination, and generated an emergency response to a threat that did not exist. This is the thermal grill illusion. It has been replicated hundreds of times. Subjects rate the pain between 5 and 7 on a 10-point scale. Some describe it as a hot iron pressed against the skin, and none of it corresponds to anything happening to their body. The pain is real inside the skull. Outside the skull, there is warm water and cool water and nothing else. Now step back and look at what we have assembled. Color is generated by the brain from wavelengths that carry no color. Sound is generated from pressure waves that carry no sound. Touch is generated from electromagnetic repulsion that involves no contact. The body itself is a map that can be hacked with a rubber glove. And pain, the loudest signal in your entire nervous system, the one you trust most because it screams, can be generated from nothing. No cause, no source, no event in the physical world that matches the suffering. 5 channels, 5 fabrications, running simultaneously, in perfect coordination, every second you are alive. This is not a collection of bugs in an otherwise reliable system. 5 parallel constructions operating in sync is architecture. Something built this, something selected for it. Something tested millions of designs over billions of years and kept the ones that lied best. That something is evolution. And it did not build this system by accident. The proof that this is a deliberate engineering and not a flaw is simple. If faulty perception were a bug, it would be random. Different species would glitch in different ways. Some would see more of reality, some less, with no pattern. But that is not what we find. Every species on this planet has a precisely customized perceptual bubble, tailored to its ecological niche, and not one of those bubbles shows a reality as it is. Jakob von Uexküll named this concept Umwelt in 1909. Consider the tick. It sits on a blade of grass and waits. It does not see color. It does not hear sound. It does not feel texture. Its entire universe consists of 3 signals: the smell of butyric acid from mammalian skin, the temperature of 37 degrees Celsius, indicating warm blood, and the tactile sensation of hair telling it where to burrow. 3 data points. That is the tick's complete reality. The sky, the wind, the forest, none of it exists for the tick. Not because it ignores these things, because its hardware has no channel to receive them. A frog's visual system detects only movement. A motionless fly sitting directly in front of a frog is invisible. The frog will starve surrounded by food if the food does not move. A pit viper reads infrared radiation and navigates in total darkness through a thermal landscape that you will never see. Each of these animals is sealed inside its own Umwelt, its own private version of the universe, and not one of them is wrong. The tick's 3-signal world works perfectly for being a tick. The frog's motion-only vision works perfectly for catching flies, but none of them are seeing what is actually there. They are seeing the slice that their nervous system was built to detect. And that slice was not selected for accuracy. It was selected for survival. Every Umwelt on this planet was carved out by the same process. The same blind engineer running the same optimization. Not for truth, for reproduction. The question is what exactly that optimization looks like. What is the rule? When evolution builds an eye or an ear or a nerve, what is it maximizing? Not truth, reproduction. Charles Darwin figured out the mechanism in 1871 when he published a book about a problem that had been bothering him for years. The peacock's tail. It made no evolutionary sense. The tail is heavy. It costs enormous energy to grow. It makes the bird slower, louder, more visible to predators. By every rule of natural selection, peacocks with large tails should have died out millions of years ago. But they did not. They thrived. Because the tail is not built for survival. It is built for the eyes of the peahen. The female peacock looks at that enormous, iridescent fan, and her nervous system fires a signal that translates roughly to good genes. The signal is not a rational evaluation. It is not a measurement of the male's health or strength. It is a perceptual shortcut. A tag, the same way your brain tags a 700 nanometer wavelength as red. The peahen does not see a tail. She sees a label that means mate with this one. Darwin called this sexual selection. And it revealed something fundamental about perception. The eyes, ears, and nervous systems of every animal on this planet were not shaped by the pressure to see reality. They were shaped by the pressure to reproduce. The frog sees only movement because movement means food, and food means survival long enough to mate. The tick detects 3 signals because those 3 signals lead it to a blood meal, and a blood meal leads to eggs. Your visual system detects 0.0035% of the electromagnetic spectrum, because that slice was enough for your ancestors to find food, avoid predators, and reproduce. Every perceptual system on Earth is an answer to the same question. Not what is true, but what is useful for making copies. The blueprint is optimized for replication. Truth is not part of the spec. But you might push back here. You might say, fine, evolution builds for reproduction, but accuracy is useful for reproduction too. An animal that sees the world more clearly should survive and reproduce more effectively than one that sees a distortion. Accuracy should be rewarded. Seeing truth should be an advantage. It sounds logical, but logic is not evidence. The Israeli biologist Amos Zahavi spent decades studying exactly this question. If evolution rewards useful signals, what makes a signal trustworthy? His answer, published formally in 1975, is called the handicap principle. A signal is reliable only if it is expensive. The peacock's tail works as a mating signal precisely because it is costly. Only a genuinely healthy male can afford to waste that much energy on decoration. A sick male cannot fake it. The cost is the proof. This sounds like evolution is rewarding honesty, but look closer. The tail does not communicate the truth about the peacock. It communicates one specific useful fact. This male has resources to burn. The peahen is not getting a complete picture of reality, she is getting a price tag. And a price tag is a label, not a description. Zahavi's work showed that every communication system in nature operates on this principle. Alarm calls in birds, territorial songs in frogs, color patterns in reef fish. Every signal is a trade, not a trade of information for information, a trade of cost for reliability. And reliability in this context does not mean true. It means useful enough to act on without getting killed. The distinction matters. A reliable signal in nature is one that correlates with fitness, with survival odds, with reproductive potential. It does not need to correlate with objective reality at all. A frog does not need to know what a fly is made of. It needs to know where to aim its tongue. The signal is precise enough to catch the fly. It is not precise enough to describe the fly. Accuracy is not being selected for. Utility is. Truth is not a feature. It is overhead. Extra processing that costs energy and delivers no reproductive advantage. Evolution does not select for overhead. It strips it out. Every unnecessary feature is a calorie wasted. And in a world where calories determine who reproduces and who dies, truth is a luxury that no species can afford. So evolution does not just fail to reward accuracy, it actively selects against it. The organisms that survive are the ones with the most efficient shortcuts, the most compressed labels, the least truth. But humans are different. We have consciousness, self-awareness. We can catch our own brain lying and correct for it. We can step outside the system and see the trick. That is what separates us from the tick and the frog. We can outsmart the filter, except we cannot. In 2011, the evolutionary biologist Robert Trivers published a book that closed this escape hatch permanently. His argument is simple and devastating. If deception is useful for survival, then self-deception is even more useful. Here is why. Imagine you are a primate living in a social group. Your survival depends on cooperation. You need allies. You need trust. But you also need to cheat occasionally, to take more than your share when no one is looking. The problem is that other primates are good at detecting liars. They read your face, your posture, your hesitation. If you know you are lying, your body leaks signals, micro-expressions, stress hormones, averted gaze. The tell is in the knowing. Trivers realized that evolution solved this problem with an elegant and terrifying hack. If the liar does not know he is lying, there is no tell to detect. So the brain evolved the ability to hide information from itself. It buries the deception below the level of conscious access. You believe your own lie, your body language is clean, your stress hormones stay flat. You pass the test because you have no idea you are cheating. Self-deception is not a flaw in human cognition. It is a feature installed by natural selection because it made our ancestors better at surviving social environments. And it means that the problem is not just that your brain filters reality, the problem is that your brain hides the fact that it is filtering. It is a double lock. The first lock removes the truth. The second lock removes your awareness that the truth was removed. You cannot catch the editor because the editor erased the evidence of editing. And you cannot feel the absence because the system that would detect the absence is the same system that created it. 5 fabricated senses, a perceptual architecture built for reproduction, not truth. A communication system that trades in labels, not descriptions. And now a self-deception engine that makes the whole construction invisible from the inside. This is the machine. And so far we have only described what it does. We have not yet explained how it works. How does the brain build this illusion in real time? What is the mechanism that constructs your entire experience of reality from scratch every waking second? The answer is one of the most important ideas in modern neuroscience, and it turns your brain into something you did not expect. The idea comes from a physicist turned neuroscientist named Carl Friston. He is currently the most cited living neuroscientist on the planet, and his framework, called the free energy principle, redefines what the brain actually does. The traditional model says the brain is a processing machine. Data comes in through the sensors, the brain analyzes it, and the result is your experience of reality. Input, processing, output. Like a computer. Friston says this model is backwards. The brain does not start with input. It starts with a prediction. Before any signal reaches your eyes or ears or skin, the brain has already generated a complete model of what it expects to find. A full simulation. A draft of reality built from memory, context, and prior experience. Then the sensory data arrives, and the brain does not use that data to build a picture. It uses the data to check the picture it already built. If the incoming signal matches the prediction, nothing happens. The brain keeps running the simulation, and you experience it as reality. If the signal does not match, the brain registers the difference as a prediction error. And here is the critical part. The brain has two options for dealing with the error. Option 1, update the model to match the data. Option 2, suppress the error and keep the model. Friston showed mathematically that the brain minimizes prediction error by default. It is not trying to build an accurate picture. It is trying to reduce surprise. And often the cheapest way to reduce surprise is to ignore the data and keep the prediction. This means that what you experience as perception is not the world coming in. It is the brain's model going out. The sensory data is a correction signal, not the main feed. You are not watching reality. You are watching a simulation that occasionally gets a note from the outside saying, "You are slightly off here." The implication is staggering. If the brain leads with prediction and the sensors only provide error correction, then the question is what percentage of your experience is prediction and what percentage is data? The answer comes from a cognitive scientist who took Friston's framework and quantified it. Andy Clark at the University of Edinburgh spent years building on Friston's work and arrived at a number that should disturb you. Roughly 90% of what you consciously experience is generated top-down by the brain's predictive model. Only about 10% comes from the actual sensory input. 90 and 10. Think about what that ratio means. Right now, you are looking at a room or a screen or a street. You assume that what you see is a picture constructed from the light entering your eyes. It is not. What you see is a movie your brain wrote, directed, and is currently screening on the inside of your skull. Your eyes are not the camera. Your eyes are the fact checker. And the fact checker only gets to review 10% of the footage. The other 90% plays unchallenged. Clark described perception as a controlled hallucination that is slightly corrected by sensory input. The hallucination is the default state. The correction is the exception. And most of the time, the correction is small enough that the brain absorbs it without changing the picture. You walk into a room and your brain has already decided what the room looks like based on rooms you have been in before. The light from this specific room hits your retina, and your brain checks the incoming data against the model. If the differences are small, the model wins. You see the prediction, not the room. This explains why eyewitness testimony is unreliable. Why you can drive for 20 minutes on a familiar road and remember nothing. Why you can look directly at a set of keys on a table and not see them because your brain's model says the keys are not there. You are living inside a forecast, a projection, a best guess that your brain is running at all times and updating only when forced. But 10% is still something. 10% is still a thread connecting you to the outside. If the brain gets 90% from its own model, at least the remaining 10% is real data pushing through. At least something from the outside is reaching you. Unless the brain cuts even that thread. Unless there is a mechanism that deletes incoming data before it reaches consciousness. There is. In 1999, cognitive psychologists Daniel Simons and Christopher Chabry ran an experiment at Harvard that has since become one of the most famous demonstrations in the history of psychology. They showed subjects a short video of 6 people passing basketballs. 3 wore white shirts, 3 wore black. The subjects were told to count the number of passes made by the white team. Halfway through the video, a person in a gorilla suit walked into the center of the frame, faced the camera, beat their chest, and walked out. The gorilla was on screen for 9 full seconds. When the video ended, the researchers asked the subjects a simple question. Did you see the gorilla? Roughly half of them said no. They did not see it. Not in the background. Not as a blur. They did not see a gorilla standing in the middle of the screen for 9 seconds while they were looking directly at it. Simons called this inattentional blindness. The brain was so focused on executing its prediction, count the passes from the white team, that it actively suppressed visual information that did not match the task. The gorilla was not filtered out by low resolution or peripheral vision. The light from the gorilla hit the retina. The signal traveled to the visual cortex. But somewhere between the cortex and conscious awareness, the brain made a decision. This does not match the model. Delete it. The gorilla was not missed. It was removed. This is the mechanism that closes the loop. The brain generates 90% of your experience from its own model. The remaining 10% comes from sensory input. And now we know that even that 10% is subject to editorial deletion. If the incoming data contradicts the prediction, the brain can simply cut it from the final product. You're not watching a slightly inaccurate movie. You're watching a movie that is edited in real time to remove anything the director did not expect. So what is the difference between this and a hallucination? Between the controlled projection running inside your skull right now and the uncontrolled projection running inside the skull of someone in a psychotic episode? The answer turns out to be much smaller than you think. Anil Seth, a neuroscientist at the University of Sussex, has spent the last decade answering that question. His conclusion is one sentence long. Normal perception is a controlled hallucination, not a metaphor, a literal description of the mechanism. In a psychotic hallucination, the brain's predictive model runs unchecked. It generates a reality, voices, figures, threats, and the sensory correction system fails to rein it in. The model overwhelms the data. The patient sees things that are not there, and the error correction system cannot flag the discrepancy. In normal perception, the exact same process is running. The brain generates a model. It projects a complete experience. The only difference is that the error correction system is functioning. It catches the major discrepancies and nudges the model back toward the sensory input. Not all discrepancies, not even most, just enough to keep you from walking into walls. Seth quantified this. He built computational models showing that the architecture of perception and the architecture of hallucination are the same neural process with a different gain setting. Turn the gain up on the predictive model and down on the error correction, you get psychosis. Turn the gain down on the model and up on the correction, you get something closer to raw sensory data, which is what happens with certain neurological conditions where patients are overwhelmed by unfiltered input. Your normal waking experience sits at a specific point on that dial, a point that evolution calibrated not for accuracy but for survival. Move the dial 1 degree in either direction, and your experience of reality changes fundamentally. And the dial is not in your hands. You did not choose the setting. You cannot access the setting. You cannot even feel the dial. You are the output of a calibration you never agreed to and cannot adjust. The distance between you and a person experiencing a psychotic break is not a wall. It is a dial position. Same machine, same movie theater, same projector, different setting. So everything you experience, every color, every sound, every touch, Every shape, every boundary of your body, every moment of pain is a controlled hallucination calibrated by evolution for survival. The machine is clear. The mechanism is mapped. But so far, everything we have covered is observational. Experiments, case studies, neural models, compelling, but not proof, not mathematics. The question is whether you can take this entire argument, every fabricated sense, every perceptual shortcut, every evolutionary trade of truth for fitness, and prove it formally, with a theorem, with a number. Someone did. His name is Donald Hoffman. He is a cognitive scientist at the University of California, Irvine, and he has spent over 30 years building the mathematical framework for what we have been describing. But before he could write the proof, he needed the right analogy, an image precise enough to carry the entire argument. He found it on his desk. Look at your computer screen. You see icons, a blue folder, a red trash can, a white document with black text. You click the folder and it opens. You drag a file to the trash and it disappears. The interface works. You get things done, but the icons are not the computer. The blue folder is not blue inside the machine. There is no folder. There are voltage changes in silicon transistors, magnetic orientations on a disk, electrical signals moving through copper at near light speed. The icon is a simplified visual symbol that lets you interact with the machine without understanding any of that. If you had to manage voltage states and magnetic fields directly, you could not send a single email. The interface is not showing you the truth. It is showing you a useful fiction. And the useful fiction is what makes the machine usable. Hoffman argues that your entire perceptual experience works the same way. The apple on the table is an icon. The table is an icon. The space between them is an icon. You interact with these icons and get results. You bite the apple and get calories. You lean on the table and it supports your weight. The interface works, but the apple does not look like whatever is actually there. The table does not look like whatever is actually there. Space itself does not look like whatever is actually there. They are symbols, useful, functional, completely unlike the underlying reality. This is the interface theory of perception, and it makes a specific, testable prediction. If perception is an interface, then organisms that see reality as it is should have no advantage over organisms that see useful fictions. In fact, they should do worse, because truth is expensive. It requires processing resources that could be spent on faster reactions, better shortcuts, more efficient survival. An organism wasting energy on accuracy is an organism losing the race to an organism that runs on labels. Hoffman did not just argue this point, he proved it. The proof is called the fitness beats truth theorem. Hoffman developed it with Chetan Prakash, a mathematician, and Manish Singh, a cognitive scientist, and they published it in 2015. The structure uses evolutionary game theory. Imagine a population of organisms in an environment. Some organisms are wired to perceive the true state of the world. They see objective reality. Call them truth organisms. Other organisms are wired to perceive fitness payoffs. They do not see what is there. They see what is useful. Call them fitness organisms. Now let them compete, generation after generation, in every environment, under every condition. The fitness organisms win. Not sometimes, not usually, every single time. The mathematics is formal. In any environment with a measurable fitness function, the probability that natural selection will favor an organism that perceives objective reality converges to 0. Not a small number, not a rounding error. 0. The theorem does not say your perception is inaccurate. Inaccurate implies you are close but off by some margin. The theorem says your perception has no relationship to reality at all. The interface you're using is not a blurry window. It is not a foggy lens. It is a completely separate layer that bears no structural resemblance to whatever is behind it. The same way a desktop icon bears no resemblance to the voltage states it represents. The blue folder icon is not a bad picture of the transistors. It is a different kind of thing entirely. And the theorem says your experience of the world is a different kind of thing from reality entirely. Think about the number. 0. Not 1%. Not a fraction. The probability that you are seeing reality is 0. This is not a philosophical position. It is not an interpretation. It is a mathematical result derived from the axioms of evolutionary game theory and confirmed by every simulation that has ever tested it. But a theorem is only as strong as its assumptions. If the model is too simple, the result might not hold in a complex real world. So they tested it. They ran thousands of simulations using genetic algorithms. A genetic algorithm is a computational method that mimics natural selection inside a computer. You create a population of digital organisms. Each one has a strategy for perceiving its environment. Some are wired to see truth. Some are wired to see fitness. You place them in an environment with resources, dangers, and reproductive opportunities. Then you press start and let evolution run, generation after generation. The organisms compete, reproduce, and die. The ones with better survival strategies pass their genes forward. The ones with worse strategies disappear. After thousands of generations, you check which perceptual strategy dominates the population. Hoffman and his team ran this simulation under every condition they could design. Simple environments, complex environments, environments with one resource, environments with hundreds, stable environments, chaotic environments, cooperative scenarios, competitive scenarios. The result never changed. In every single simulation, the truth-perceiving organisms went extinct. Every time. The fitness-perceiving organisms survived and dominated. Every time. Not in 99% of runs, in 100%. Not with some advantage, with total dominance. The truth organisms did not come close. They did not put up a fight. They vanished. Because seeing reality costs processing power that could be spent on faster decisions. An organism that computes the true state of its environment is slower than an organism that computes a shortcut. And in evolution, slower means dead. The simulations confirmed the theorem. 0 is not an artifact of the math. 0 is the outcome in practice. Under every condition ever tested, evolution produces organisms that see none of the underlying reality. Your brain is the product of this process. 3.8 billion years of selection pressure that rewarded every mutation moving perception further from truth and closer to utility. You are not a slightly inaccurate observer. You are an organism that was specifically engineered to see something other than reality. But so far we have been talking about senses, color, sound, touch, the things your brain constructs. Hoffman's theorem implies something much larger. If perception is an interface that bears no resemblance to reality, then the interface includes everything, not just the colors and sounds, the stage they appear on. Think about what an interface needs to function. It needs a coordinate system. Your computer screen has pixels arranged in rows and columns. Every icon has a position defined by X and Y coordinates. Those coordinates are real on the screen. You can point to them, you can measure them, but they are not real inside the computer. The transistors in the processor do not have a position on a two-dimensional grid. They exist in a completely different organizational structure. The XY grid is a feature of the display, not a feature of the machine. Hoffman's extension of the FBT theorem makes the same argument about space and time. Space is not a container that exists out there, holding objects in fixed positions. Space is the coordinate system of your perceptual interface. It is how your brain organizes the icons. Time is not a river, flowing from past to future. Time is the refresh rate, the frame rate at which your brain updates the simulation. These are not metaphors. Hoffman means this literally. The theorem proves that fitness-tuned organisms do not see reality, and space and time are part of what you see. Therefore, space and time are part of the interface, not part of reality. You experience yourself as sitting in a specific location at a specific moment. You feel the distance between you and the wall. You feel the seconds passing. Those experiences are as constructed as the color red. They are the operating system of the hallucination, the grid on which all the other icons are placed. Think about the GPS in your phone. It calculates your position using signals from satellites and corrects for the curvature of space-time predicted by Einstein's equations. If space and time were simple, objective facts, no correction would be needed. But corrections are needed every second because time passes at different rates depending on velocity and gravity. Space and time bend, stretch, and compress depending on the observer. They are not fixed, they are variable. And variables that change based on the observer are not properties of the world. They are properties of the observation. The interface goes all the way down. Not just color, not just sound, not just touch, not just your body, not just pain. The very stage on which all of those experiences play out, the spatial and temporal framework of your existence, is part of the construction. But if that is what the math says, if one cognitive scientist theorem claims that space and time are features of a display, then physics should either confirm it or destroy it. What does physics say about space and time? In 1905, a patent clerk in Bern, Switzerland, published a paper that demolished the idea of absolute time. His name was Albert Einstein, and his theory of special relativity contained a result so counterintuitive that physicists argued about it for decades. The result is called the relativity of simultaneity. Here is what it means. Imagine two events. A lightning bolt strikes the front of a train, and another strikes the back. A person standing on the platform midway between the two strikes sees them happen at the same time, simultaneous. But a person sitting on the train, moving toward the front strike and away from the rear strike, sees the front bolt hit first. Not because of a delay in perception, not because light took longer to reach their eyes. The two events are genuinely simultaneous for one observer and genuinely sequential for the other. Both are correct. Neither is wrong. There is no absolute fact of the matter about which happened first. 10 years later, Einstein extended this with general relativity. Gravity bends time. A clock on a mountaintop ticks faster than a clock in a valley. Not because the clocks are broken, because time itself passes at different rates, depending on the strength of the gravitational field. This is not theory. The GPS satellite network confirms it every second of every day. Each satellite carries an atomic clock. Those clocks tick faster than clocks on the surface of the Earth by about 38 microseconds per day because the satellites experience weaker gravity. If the system did not correct for this difference, your GPS position would drift by roughly 10 kilometers per day. The correction is built into the software. It is engineering, not philosophy. So time is not a river that flows at a constant rate for everyone. Time is a variable that depends on speed and gravity. It changes based on the conditions of the observer. A variable that shifts depending on who is measuring it is not a property of the external world. It is a property of the measurement. Hoffman's interface theory said space and time are part of the display. Einstein proved that time behaves exactly like a display parameter. Different observers, different readout. But time is at least something. It may be relative, but it exists in the equations. It has a role in the physics. What about the deeper layer? What about the stuff that fills space and time? What about matter itself? Surely physical matter, atoms, particles, the substrate of the universe, exists independently of anyone looking at it. One of the people who would have agreed with that assumption is John Archibald Wheeler. Wheeler was not a fringe thinker. He was one of the most important physicists of the 20th century. He coined the term black hole. He worked with Niels Bohr on nuclear fission. He supervised Richard Feynman's doctoral thesis. And in the last decades of his career, he arrived at an idea that dismantled the assumption that matter is fundamental. He called it from bit. The idea is 3 words long, but the implications are bottomless. Wheeler argued that every physical quantity, every particle, every field, every force derives its existence from answers to binary questions. Yes or no, on or off, 1 or 0. A particle does not have a position until a measurement asks, "Where is it?" and gets an answer. An electron does not have a spin until an experiment asks up or down and gets a result. Before the question is asked, the property does not exist in an undefined way. It does not exist at all. The bit of information, the answer to the yes-no question, is what brings the physical thing into being, not the other way around. Matter does not generate information. Information generates matter. This is not a metaphor Wheeler was using to explain quantum mechanics to journalists. This was his ontology, his claim about what the universe actually is, and it aligns precisely with what we have been building. If your perception is an interface, the icons on the screen are not the reality. They are representations, symbols. And what are symbols made of? Information. A desktop icon is a small packet of information that your computer displays as a colored shape. Wheeler is saying that a particle is a small packet of information that the universe displays as a physical object. The substance you knock on when you knock on a table is not fundamental. It is a rendered output. A display of underlying information, the same way the blue folder on your screen, is a display of underlying voltage states. Hoffman says you see an interface. Wheeler says the universe is information being displayed. The two frameworks point in the same direction. Matter is not the ground floor. Matter is the screen. But if matter is a display and space and time are the coordinate grid, then surely the grid itself is fundamental. The coordinate system has to be the bedrock. Space and time may be relative, they may bend and stretch, but they are the framework inside which everything happens. Remove space and time, and there is nowhere for physics to take place. That is what physicists believed for a century. And then a theoretical physicist at the Institute for Advanced Study showed that the best physics happens when you remove them entirely. Nima Arkani-Hamed is one of the leading theoretical physicists alive today. In 2013, he and his collaborator Jaroslav Trinka discovered a geometric object called the amplituhedron. To understand what it does, you need to know what problem it solves. When physicists calculate what happens when subatomic particles collide, they use a method developed by Richard Feynman. You draw diagrams, Feynman diagrams, that represent every possible way the particles could interact. Each diagram is a term in an equation. For a simple collision, you might have a few diagrams. For a complex one, thousands. Each diagram involves integrals calculated across space and time. The math works, but it is brutally complex. Some calculations that should be simple require pages of equations and months of computation. Arkani-Hamed found that all of those diagrams, thousands of terms, pages of integrals, could be replaced by a single calculation. The volume of a geometric shape, the amplituhedron, one shape, one number, same answer. But here is what matters for our story. The amplituhedron does not use space or time. The shape exists in an abstract mathematical space that has no spatial dimensions and no temporal axis. Space and time are not inputs to the calculation. They are outputs. They emerge from the geometry after the calculation is done. The physics works better without them. Removing space and time from the foundation does not break the equations. It simplifies them, dramatically. It is like discovering that a machine runs smoother when you remove a part you thought was essential. The part was not supporting the machine, it was adding friction. Arkani-Hamed has been explicit about the implication. Space and time, he argues, are not fundamental features of reality. They are approximate, emergent properties that appear at large scales the same way the smooth surface of a table appears solid when you are actually looking at a cloud of atoms with vast empty space between them. Hoffman's theorem says space and time are part of the interface. Einstein showed time is observer-dependent. Wheeler showed matter is information. And now Arkani-Hamed shows that the deepest physics does not need space or time at all. The interface theory is not just a cognitive hypothesis. Physics itself is converging on the same conclusion. But if space and time are not fundamental, if matter is information being displayed, Then what is behind the display? What do you find when you look past the interface? The answer is the strangest experimental result in the history of science, and it has been confirmed so many times that no serious physicist disputes it. Every experiment we have discussed so far has been peeling back layers of an interface. Color was a tag, sound was a translation, touch was a misreading, space and time were a coordinate grid. But through all of that stripping, there was an unspoken assumption that behind the interface, there is still a world. A different world, a strange world, a world we cannot directly perceive, but still something that behaves the way worlds behave. Something with objects in it, something with locations, something with a before and an after. That assumption is about to break. Because when physicists finally manage to look behind the interface, to examine what happens at the smallest scale the universe allows, they did not find a stranger version of the world. They found something that does not follow the rules of any world you have ever imagined. At the quantum level, objects do not have definite properties until they are measured. Particles do not travel along paths. Causes do not always precede effects. The very concept of something existing in a specific place at a specific time stops applying. This is not a gap in our knowledge. It is not that we lack the instruments to see what is really happening. The mathematics is explicit. The experiments are repeatable. What we find at the bottom is not a hidden reality waiting to be uncovered. It is a domain where the word reality stops meaning anything you recognize. You spent the last hour learning that your interface lies about color, sound, touch, body, pain, space, and time. Now we go behind the interface, and behind it there is nothing your brain was built to comprehend. The first experiment that proved this is also the most famous. It has been replicated thousands of times in laboratories on every continent. It is simple enough to describe in a few sentences, and its implications have not been fully absorbed by the human species even after 100 years. It involves a wall, 2 slits, and a single particle. Fire a single photon at a barrier with 2 narrow slits. On the other side, place a detector screen that records where the photon lands. Do this thousands of times, 1 photon at a time. If the photon were a tiny ball, it would pass through one slit or the other, and you would see 2 clusters on the screen, one behind each slit. That is not what happens. The photons form an interference pattern, alternating bands of light and dark, the signature of a wave passing through both slits simultaneously and interfering with itself on the other side. A single particle behaving as a wave going through 2 openings at once. But that is only half the result. Now add a detector at the slits, a device that records which slit the photon actually passes through. The moment you add the detector, the interference pattern vanishes. The photon starts behaving like a particle. It goes through 1 slit, 1 cluster behind each opening. No interference, no wave behavior. The photon did not change. The slits did not change. The screen did not change. The only thing that changed is that you looked. The act of observation collapsed the wave behavior into particle behavior. The act of not observing allowed both possibilities to coexist. This experiment was first performed with light by Thomas Young in 1801. It was repeated with single electrons by Akira Tonomura in 1989. It has been done with atoms, with molecules, with objects containing over 800 atoms. The result is always the same. When you do not observe, the particle exists in a superposition, a state where multiple possibilities are real simultaneously. When you observe, the superposition collapses into one definite outcome. You do not discover which slit the particle went through. You cause it to go through one. The observation does not reveal a pre-existing fact. It creates the fact. But this raises an obvious objection. Maybe the particle did go through one slit all along. Maybe it had a definite path and a definite position, and our measurement just revealed it. Maybe there is a hidden layer of reality underneath, a set of secret variables that determine the outcome before we look. For 50 years, that was a respectable position. Then a physicist in Belfast proved it wrong. In 1964, John Stuart Bell, a physicist at CERN, derived a mathematical inequality that could settle the question once and for all. The logic behind it is elegant. If particles have hidden properties that determine their behavior before measurement, those properties must obey certain statistical constraints. Bell expressed those constraints as a set of inequalities. If the hidden variables exist, the inequalities hold. If they do not exist, the inequalities are violated. The experiment is conceptually simple. Create a pair of entangled particles, send them in opposite directions, measure a property of each one, such as spin, along randomly chosen angles, record the results, do it thousands of times, then compare the statistics. If the correlations between the two particles' measurements obey Bell's inequality, hidden variables are real. The particles had definite properties all along, and we were simply uncovering them. If the correlations violate the inequality, hidden variables are impossible. The properties did not exist before measurement. In 1982, the French physicist Alain Aspect performed the definitive version of this experiment at the University of Paris. He measured entangled photons with settings that changed randomly while the photons were in flight, eliminating any possibility that the particles could communicate or coordinate. The result was unambiguous. Bell's inequality was violated, by a wide margin, exactly as quantum mechanics predicted. The hidden variables do not exist. The particles' properties are not secret values waiting to be revealed. They are not there, not unknown, not hidden, absent. The property comes into existence at the moment of measurement, and not one instant before. This result has been confirmed in progressively tighter experiments for over 40 years. In 2015, a team in Delft closed the last remaining loopholes simultaneously in a single experiment. The conclusion held: there is no hidden reality underneath the quantum measurement. The measurement is where reality begins. So the interface is not hiding a deeper world that looks like a world. Behind the measurement, there is not a particle sitting somewhere with a definite spin waiting to be found. There is a mathematical structure, a probability cloud, and the act of observation pulls a definite outcome out of that cloud. But you might accept this and still hold one position. Fine. The present is created by observation, but the past is fixed. What already happened cannot change. The photon went through the slit, the measurement was made, the fact was recorded. The past at least is solid ground. John Wheeler, the same physicist who gave us It from Bit, designed a thought experiment in 1978 that attacked this last refuge. He called it the delayed choice experiment. It was physically realized in a laboratory in 2007, and the result confirmed his prediction exactly. The setup is a variation of the double slit. A photon is fired at the slits. After it has already passed through, after the moment where it would have gone through one slit or both, the experimenter makes a choice. They either turn on a detector that determines which path the photon took, or they leave the detector off and allow the interference pattern to form. The choice is made after the photon has passed the slits, after the event that the choice is supposed to affect has already occurred, and the choice changes the outcome. If the detector is turned on after the photon passes the slits, the photon behaves as if it went through one slit. No interference. Particle behavior. If the detector is left off after the photon passes the slits, the photon behaves as if it went through both. Full interference. Wave behavior. The decision made in the present determines what the photon did in the past. Not what it appears to have done. What it actually did. The interference pattern is a physical record. It is not a matter of interpretation. The pattern either forms or it does not. And the pattern changes based on a choice that had not been made at the time the photon was at the slits. Wheeler was careful about the implication. He did not say that information travels backward in time. He said something more radical. The past does not exist in a definite form until a present observation selects it. The history of the photon is not a fixed sequence of events that your measurement reveals. The history is created by the measurement. The past is as dependent on the observer as the present. This is not philosophy overlaid on physics. This is a laboratory result replicated in multiple independent experiments. The arrow of time, the feeling that the past is solid and the future is open, is a feature of the interface. Behind the interface, the distinction between past and future does not hold the way your brain insists it does. But there is one final escape. You could accept all of this, every experiment, every theorem, and still argue that there must be one objective reality underlying it all. Observers may create facts, the past may be fluid, but surely when two observers look at the same event, they converge on the same result. Surely at the end of the day, there is one truth that everyone agrees on. In 2018, a group of physicists proved that even this is not guaranteed. The thought experiment was originally proposed by the physicist Eugene Wigner in 1961 and extended by Daniela Frauschka and Renato Renner in 2018 into a full no-go theorem. The setup involves two observers, each performing a quantum measurement on the same system, and then comparing their results. In classical physics, this is trivial. Two people measure the same object. They get the same answer. That is what objective reality means. One truth, independent of who looks. But in the Frauschka-Renner scenario, the two observers can arrive at results that are mutually contradictory. Not because one made an error. Not because the measurement was imprecise. Both observers followed the rules of quantum mechanics perfectly. Both got valid results. And the results disagree. The theorem proves that you cannot simultaneously maintain three things that most people assume are all true. That quantum mechanics is universal, meaning it applies to all systems including observers. That measurements have single definite outcomes, and that different observers can agree on those outcomes. At least one of these must be false. If quantum mechanics is universal and measurements have definite outcomes, then different observers can get different facts about the same event. If observers must agree, then either quantum mechanics is not universal or measurements do not have definite outcomes. There is no option where all three survive. The experiment was realized in a simplified form in 2019 at Heriot-Watt University in Edinburgh. The results were consistent with the theorem. The implications are precise. Objective reality, a single set of facts that all observers share, is not a guaranteed feature of the universe. It may not exist, not hidden, not hard to access, not buried under layers of quantum complexity. It may simply not be there. Two observers, one event, two incompatible truths, both valid. This is what you find behind the interface. Not a strange version of the world, not a confusing version. A domain where the concept of the world, a single objective place that exists independently of observation, stops being coherent. You peeled back color. You peeled back sound and touch. You peeled back space and time. You arrived at the quantum level and found that the last thing you were holding onto, the idea that there is one real world underneath it all, is not supported by the physics. But if there is no single objective reality, and if everything you experience is a constructed interface, then the question turns inward. What is the thing that is experiencing the construction? What is the observer? What is consciousness? And why can physics not explain it? We have spent the entire journey so far dismantling what you perceive. Color, sound, touch, body, pain, space, time, matter, the past, objective reality. Layer after layer removed. But through all of that demolition, one thing has been constant. You. The thing that is reading these words. The thing that felt uneasy when it learned that touch is electromagnetic repulsion. The thing that tried to imagine a photon going through two slits at once. There is something it is like to be you. There is a felt quality to your experience. Red does not just trigger a neural response. It looks like something. Pain does not just activate C fibers. It feels like something. And this felt quality This subjective inner experience is the one piece of the puzzle that no experiment we have discussed can explain. In 1995, the philosopher David Chalmers gave this gap a name. He called it the hard problem of consciousness. The easy problems of consciousness are the ones neuroscience can handle. How does the brain process visual information? How does it integrate signals from different senses? How does it control attention, sleep, behavior? These are engineering problems. Complex but solvable. The hard problem is different. Why does any of this processing produce subjective experience? Why does a specific pattern of neural firing feel like the color red instead of feeling like nothing at all? A thermostat detects temperature and adjusts the heating. It processes information, but there is nothing it is like to be a thermostat. A computer processes billions of calculations per second, but there is presumably nothing it is like to be a laptop. Your brain processes information, and somehow, through a mechanism no one can identify, there is something it is like to be you. Chalmers pointed out that you can know everything about the physical structure of the brain, every neuron, every synapse, every chemical signal, and still not explain why subjective experience exists. The physical facts do not contain the experiential fact. You can predict what a brain will do. You cannot predict what it will feel. This is not a gap in current knowledge. It is a gap in the kind of explanation that physics can provide. Physics describes what happens. It does not explain why it feels like something. And if physics cannot explain the observer, maybe the observer is not a product of physics. Maybe consciousness is not something that emerges from matter. Maybe it is something more fundamental. Is there a way to measure it? Giulio Tononi, a neuroscientist at the University of Wisconsin-Madison, believes there is. In 2004, he proposed a theory called integrated information theory, or IIT. The core idea is precise. Consciousness is not a thing. It is not a substance. It is not a soul or a spark. Consciousness is a measurable quantity. He calls it phi. Phi is a number that represents how much integrated information a system generates above and beyond its individual parts. If a system is just a collection of independent components that do not interact, phi is 0. No integration, no consciousness. But if the components are wired together in a way that creates information that only exists in the interaction between them, information that disappears if you split the system apart, then phi is greater than 0. And the higher the phi, the richer the conscious experience. A photodiode has a tiny amount of phi. It integrates one bit of information, light or no light. Tononi would say it has a minimal flicker of experience. A human brain integrates billions of signals across hundreds of billions of connections. Its phi is astronomically high. And here is the part that separates IIT from every previous theory of consciousness. Phi is not tied to biology. It is tied to information structure. If you build a silicon circuit that integrates information the same way a brain does, that circuit has the same phi. It has the same consciousness. Not a simulation of consciousness. Consciousness. The substrate does not matter. Carbon, silicon, light, quantum fields. What matters is the pattern, the architecture of integration. Tononi gave consciousness an address, not in the brain, not in biology, in mathematics. A number, computable in principle. And that number describes a property of information, not a property of matter. This connects directly to what Wheeler said, it from bit. If matter is information being displayed, and if consciousness is a property of integrated information, then consciousness is not a byproduct of the physical world. It is embedded in the same layer that generates the physical world, information all the way down. And one physicist believed it goes even deeper than that. Roger Penrose thought so. In 1989, the Nobel laureate mathematician and physicist published a book arguing that consciousness cannot be produced by classical computation. His reasoning was technical, but the conclusion was sharp. The brain is not a computer in the way we normally use the word. A classical computer follows an algorithm, step by step, rule by rule. Penrose demonstrated, using Gödel's incompleteness theorem, that human understanding does things that no algorithm can do. We grasp truths that are not reachable by any step-by-step procedure. If the brain were a classical computer, this would be impossible. Therefore, Penrose argued, something non-computational is happening in the brain, and the only known physical process that is non-computational is quantum mechanics. In the mid-1990s, Penrose teamed up with Stuart Hameroff, an anesthesiologist at the University of Arizona, to propose a specific mechanism. They identified structures inside neurons called microtubules, tiny protein tubes about 25 nanometers in diameter. Hameroff had been studying these structures for years and believed they were capable of maintaining quantum coherence at biological temperatures. Their joint theory, called orchestrated objective reduction, or ORC-OR, proposes that consciousness arises from quantum computations in the microtubules. These computations are not classical. They are not step-by-step. They involve quantum superposition, the same phenomenon we saw in the double-slit experiment, happening inside your neurons. And the collapse of that superposition, the moment when multiple possibilities become one definite experience, is what produces a moment of consciousness. If ORC-OR is correct, the implications fold back into everything we have built. The observer is not outside the quantum world looking in. The observer is quantum. The same superposition that governs particles in a lab is governing the process that generates your experience. You are not made of different stuff than the photon going through the slits. You are the same kind of process. The observer and the observed are not separate categories. They are the same fabric, the same mathematics, the same information. A fold in a sheet looking at another part of the sheet and calling it the world. But if the observer is not separate from the observed, if consciousness and matter are both patterns in the same informational fabric, then what is the fabric? What is the fundamental layer? Hoffman has an answer, and it inverts everything. For your entire life, you have operated under one assumption so basic that you never thought to question it. Matter is fundamental. Consciousness is secondary. The physical world exists first. Atoms, molecules, brains, and consciousness emerges from the complexity of the physical structure at some point. Brain produces mind. Hardware produces software. Hoffman says the arrow goes the other direction. His framework is called conscious realism. It proposes that consciousness is not a product of matter. Matter is a product of consciousness, not human consciousness specifically, not your consciousness. Consciousness as a fundamental feature of reality, the way mass or charge are fundamental in physics. In conscious realism, the basic unit of reality is not a particle. It is a conscious agent, a simple entity that has experiences, makes decisions, and interacts with other conscious agents. The physical world, everything you see, touch, and measure, is the interface that these agents use to interact with each other. Think back to the desktop metaphor. The icons on your screen are not the computer. They are the interface that lets you interact with the computer. Hoffman is saying that atoms, molecules, stars, and galaxies are not reality. They are the interface that conscious agents use to interact with each other. You see a table. The table is an icon in the interface. Behind the icon is not wood and atoms. Behind the icon is a network of conscious agents interacting in a way that your perceptual system renders as a solid brown rectangle. You see another person. That person is an icon. Behind the icon is not flesh and neurons. Behind the icon is another conscious agent whose interaction with you is rendered by your interface as a face, a voice, a body. This inverts the hard problem. Chalmers asked how consciousness arises from matter. Hoffman says it does not. Matter arises from consciousness. The question was backwards. And if this sounds too radical, consider that it solves a problem that the materialist framework has failed to solve for 400 years. No one has ever explained how physical processes produce subjective experience. Every attempt hits the same wall. Hoffman removes the wall by removing the assumption that physics is the ground floor. Consciousness is the ground floor. Physics is the interface. But if reality is a construction generated by consciousness, then a new question becomes unavoidable. Can consciousness build constructions inside constructions? Can the interface contain another interface? Can the simulation run a simulation? In 2003, a philosopher at Oxford University named Nick Bostrom published a short paper with a very long shadow. The paper is only 14 pages. The argument is only 3 steps. And one of the 3 conclusions is that you are almost certainly not experiencing base reality. Bostrom's argument is not about physics or neuroscience. It is about statistics. He begins with a simple premise. Any sufficiently advanced civilization will eventually gain the computational power to simulate conscious beings. Not cartoons, not approximations. Fully conscious minds that experience a reality indistinguishable from the one you're experiencing now. If that premise is true, then one of 3 things must be the case. Option 1. All civilizations destroy themselves or lose interest before reaching the computational threshold. No one ever builds the simulation. Option 2. Civilizations reach the threshold, but choose not to run ancestor simulations. They have the power, but they decline. Perhaps for ethical reasons, perhaps for reasons we cannot imagine. Option 3. Civilizations reach the threshold and they run the simulations. If option 3 is true, the math is simple and devastating. A single civilization running a single simulation produces billions of simulated conscious beings. Those simulated beings live in a world that looks real to them. If the simulation is good enough, some of those simulated beings eventually build their own simulations. Now you have simulated civilizations running simulated simulations. Each layer produces billions more conscious observers. Within a few generations of nesting, the number of simulated observers exceeds the number of original observers by a factor of billions or trillions. And if you are a conscious observer, the probability that you happen to be one of the tiny handful of originals, rather than one of the trillions of copies, approaches 0. Bostrom does not claim we are in a simulation. He claims that one of the 3 options must be true, and 2 of them have the same practical consequence. You cannot determine whether you are original or simulated. The test does not exist. This connects to everything we have built. Hoffman says perception is an interface. Wheeler says matter is information. Tononi says consciousness is a property of information. Bostrom says information can be nested. Interface inside interface inside interface. But how realistic is this? Is the computational power required actually achievable? Or is this just philosophy dressed as mathematics? Rizwan Virk thinks it is. Virk is a computer scientist and venture capitalist from MIT who spent years calculating what it would actually take to simulate a reality indistinguishable from this one. His analysis starts with a number you already know: Moore's law. In 1965, Gordon Moore observed that the number of transistors on a microchip doubles roughly every 2 years. This has held for 6 decades. In 1971, a chip had 2,300 transistors. By 2024, Apple's M4 chip contained 28 billion. That is a factor of over 12 million in 50 years. The trend is not slowing. And transistor count is only one axis. Memory, bandwidth, parallel processing, and algorithm efficiency are all improving on similar curves. Virk calculated that at current rates of acceleration, within a few centuries, humanity would possess enough computational power to simulate a universe with the resolution and complexity of this one. Not a cartoon, not a simplification. A full physics simulation with conscious observers who experience a reality they cannot distinguish from base reality. Now run Bostrom's statistics on that timeline. One civilization reaches the threshold. It runs 1,000 simulations. Each simulation contains a civilization that eventually reaches the threshold and runs 1,000 of its own. 3 layers deep, and you have 1 billion simulated realities and 1 original. The number of conscious observers in simulations outnumbers the observers in base reality by a factor of 1 billion to 1. If you are a conscious observer and you have no way to determine which layer you are on, the probability that you are the original is 1 in a billion. Not small, negligible. And this is a conservative estimate. 3 layers, 1,000 simulations per layer. The actual numbers could be far larger. Vogt's contribution is not philosophical, it is engineering. He is not asking whether simulation is possible in principle. He is calculating when it becomes possible in practice. And the answer is not in some unimaginable far future. It is within the technological trajectory that humanity is already on. But all of this depends on one assumption: that a simulation can be distinguished from the original. That somewhere in the code there is a seam where the physics breaks down and the scaffolding shows through. A physicist at MIT spent his career proving that the seam does not exist. Seth Lloyd is a professor of mechanical engineering and physics at MIT. He is one of the pioneers of quantum computing, and in 2006, he published a book in which he argued that the universe is not like a computer. The universe is a computer, not a metaphor, a literal quantum computer that has been running since the Big Bang. His reasoning starts with a basic observation. Every physical interaction in the universe is an exchange of information. When 2 particles collide, they exchange quantum states. When a photon hits an electron, information is transferred. Gravity, electromagnetism, the strong and weak nuclear forces, every fundamental interaction can be described as a computation. Inputs, transformations, outputs. The laws of physics are the algorithms. Particles are the data. The universe computes itself. Lloyd calculated the total number of elementary operations the universe has performed since the Big Bang. The number is roughly 10 to the power of 122. That is a 1 followed by 122 zeros. Every physical event that has ever occurred, from the formation of the first hydrogen atoms to the firing of the neurons in your brain right now, is a computation within that total. Now, consider what this means for the simulation question. If the universe is already a computation, then asking whether it is a simulation is asking whether a computation can be distinguished from a computation. A simulation is a computation that models a system. The universe is a computation that is the system. There is no difference in kind, only a difference in framing. It is like asking whether the text on your screen was typed or generated. The characters are the same. The display is the same. The information is the same. The distinction between original and copy dissolves because both are the same type of process. Lloyd's framework eliminates the seam, not because the simulation is too good to detect, because the categories of real and simulated do not apply to a universe that is fundamentally computational. You cannot find the boundary between the simulation and reality because the boundary does not exist. The computation is the reality. The reality is the computation. There is no outside. But humans do not give up easily. If there is no seam to find and no boundary to cross, then surely there is a test. A logical test. An experiment you can design from inside the system that determines whether the system has an outside. You do not need to cross the boundary. You just need to prove it exists. There must be a way to check. There is not. And the reason is not technical. It is logical. Any test you design is a process running inside the system you are testing. The instrument is made of the same material as the thing it measures. The ruler is built from the same atoms as the table. The thought experiment is generated by the same brain that generated the question. This is not a limitation of current technology. It is a structural impossibility. To verify whether your reality is a construction, you would need an observation point outside the construction. But every observation you can make is inside it. Your eyes are part of the interface. Your instruments are part of the interface. Your logic is part of the interface. Your doubt is part of the interface. The feeling you have right now, the sense that surely there must be a way out, that is also part of the interface. It is generated by the same system that generates everything else you experience. Philosophers call this the problem of self-reference. You cannot use a system to validate itself any more than you can use a dictionary to prove that the language it is written in is real. The words define each other. The circle never opens. Gödel proved a version of this in 1931. No sufficiently complex system can prove its own consistency from within. There is always a statement that is true but unprovable within the system. You need to step outside to see it. And there is no outside. Not because the door is locked. Because the door is part of the wall. The lock is part of the wall. The hand reaching for the lock is part of the wall. And the thought that says I will find a way through is generated by the wall itself. This is the bottom of the spiral. We started with color. A simple tag your brain attaches to a wavelength. We moved through sound, touch, body, pain. We discovered that evolution built every one of these fabrications deliberately. We learned that the brain constructs 90% of your experience before any data arrives. We saw a mathematical theorem that puts the probability of seeing reality at exactly 0. We watched physics dismantle space, time, matter, the past, and objective reality. We followed consciousness to a level where observer and observed are the same fabric. We considered that the fabric itself might be nested, layer inside layer, with no way to count the layers. And now we are here. At a point where verification is impossible. Not because we lack the tools, because the concept of verification requires an outside and there is no outside. The spiral is closed, 0%, and no way to check. So is this a death sentence? Is this the end? 250 years before Donald Hoffman, before quantum mechanics, before neuroscience, before computers, a man in Königsberg, Prussia, sat at a desk and arrived at the same conclusion through pure reasoning. His name was Immanuel Kant. In 1781, he published the Critique of Pure Reason, one of the most important books in the history of human thought. His central argument is this: we never experience the world as it is. We experience the world as our mind structures it. Space, time, causality, these are not features of reality. They are features of the human mind imposed onto reality. The thing as it actually is, the Ding and Sich, the thing in itself, is permanently inaccessible to us. We see the phenomenon, the appearance. We never see the noumenon, the thing behind the appearance. Kant did not have brain scans. He did not have genetic algorithms. He did not have the double-slit experiment. He reached this conclusion through logic alone. And he was right. Every discovery we have made in the last 250 years confirms his framework. Neuroscience confirmed that perception is a construction. Evolutionary biology confirmed that the construction serves fitness, not truth. Mathematics confirmed that the probability of seeing truth is 0. Physics confirmed that space, time, and matter are not what they appear. Kant's wall, the boundary between the phenomenon and the noumenon, is the same wall Hoffman calls the interface. It is the same wall the quantum physicists hit when they tried to look behind the measurement. The names change, the wall does not. But here is the part that matters most. Kant published his book in 1781, and the world did not stop. In the 250 years since, humanity discovered electromagnetism, invented antibiotics, eradicated smallpox, split the atom, built computers, mapped the human genome, and landed on the moon. Every single one of those achievements was accomplished by organisms that sees 0% of reality, using an interface that bears no resemblance to whatever is behind it. The wall did not stop a single discovery. It did not prevent a single cure. It did not block a single equation. Knowing that you cannot see reality does not make you helpless. It makes you honest. And Hoffman himself explains what that honesty reveals about the nature of the interface. It is a tool. Hoffman himself makes this point with the same analogy he started with. Go back to the desktop. The blue folder icon is not the truth about the file. It is not a transparent window into the voltage states of the transistors. But it is not a lie either. When you drag the icon to the trash, the file gets deleted. When you double-click, The document opens. The icon does not show you reality, but it lets you act on reality effectively. If you try to delete a file by manually rearranging the voltage states of each transistor, you would fail. The task is too complex. The interface simplifies it to a gesture. Drag and drop. Done. The simplification is not a flaw. It is the entire point. An interface that showed you the full truth would be unusable. Imagine a desktop that displayed the actual state of the hardware. Billions of transistors switching between voltage states millions of times per second. You could not find a file. You could not write a sentence. The information would be technically accurate and functionally useless. The same applies to your perception. Evolution did not give you reality because reality would be useless to a primate trying to find food, avoid predators, and raise offspring. What evolution gave you is a simplified, action-oriented interface that lets you interact with whatever is behind it without needing to understand it. You buy an apple icon and get calories. You step off a cliff icon and get injured. The interface is calibrated. It works. You can fly a drone by watching a screen, without ever seeing the drone itself. You navigate the screen. The drone navigates the world. The screen bears no resemblance to the physical drone, but it gives you everything you need to fly it. Your perceptual system is that screen. Hoffman argues that calling this a lie misses the point entirely. A lie is a distortion of the truth. The interface is not a distortion. It is a different format. The desktop is not a bad picture of the computer. It is a user interface designed to make the computer usable. Your perception is not a bad picture of reality. It is a user interface designed to make survival possible. And the fact that it works, that you are alive, reading this, thinking about this, questioning this, is proof that the interface is extraordinary. Not despite showing you 0% of reality, because it shows you 0%. The simplification is the gift. But knowing this, standing at the bottom of the spiral with the exit sealed, how do you live with it? How do you walk out of this and go back to a life that you now know is built entirely from a construction you cannot verify? Richard Feynman won the Nobel Prize in Physics in 1965 for a theory that describes how light interacts with matter at the quantum level. He understood the mathematics of reality better than almost anyone who has ever lived. And he said this: "I think I can safely say that nobody understands quantum mechanics, not as a joke, not as false modesty, as a factual description of the situation." The man who could calculate the behavior of photons and electrons with more precision than any human before him openly stated that he did not understand what the calculations meant. He could predict what a particle would do. He could not explain what a particle is, and this did not slow him down for a single day. Feynman played bongo drums in a samba band. He picked locks at Los Alamos for fun. He learned to draw, taught himself Portuguese, and spent afternoons in strip clubs sketching the dancers because he found human movement fascinating. He once drove across the country to witness a total eclipse and described it as one of the best experiences of his life. He was not a man paralyzed by the limits of knowledge. He was a man liberated by them. He did not need to understand the foundation of reality to be fully alive inside it. And he was not alone. Newton could not explain what gravity was. He described how it worked with extraordinary precision, but admitted that the mechanism was a mystery. He published anyway. Einstein never accepted the full implications of quantum mechanics. He spent the last 30 years of his life trying to find a way around it. He failed. He kept working. Kant knew that the thing in itself was inaccessible. He wrote 3 of the most important books in human history after reaching that conclusion. Every scientist in this video stood at the same edge, the edge where knowledge meets the wall and the wall does not move. And every single one of them kept going. Not because they found a way through, because they realized that the wall is not an obstacle. It is the landscape, the territory you work in, the game you play. You do not need to see reality to live a life. You have never seen reality. Not for 1 second since the day you were born. And look at what you have done anyway. Every friendship, every skill, every meal you enjoyed and every problem you solved. All of it accomplished by an organism running on 0% of reality. The interface was enough. It was always enough, and it is not going anywhere. So here you are, at the end of the spiral. You started at the top, looking at a screen, trusting your eyes. And then layer by layer, the ground gave way. Color was a tag your brain invented. Sound was pressure waves translated into a private soundtrack. Touch was electromagnetic repulsion that your nervous system dressed up as contact. Your body was an internal map that could be rewritten with a rubber glove. Pain was a signal that could fire without a cause. Evolution built every one of these fabrications on purpose because truth was a luxury and survival was not. Your brain turned out to be a projector, not a camera, generating 90% of your experience before any data arrived, and deleting the rest if it did not fit the script. A mathematical theorem proved that the probability of seeing reality is exactly 0. Physics confirmed it from the other side. Time is relative, matter is information, space is emergent. The quantum world creates facts only when observed and refuses to maintain a single version of events. Consciousness turned out to be the one thing that could not be explained by the physical world it was supposed to emerge from. And at the very bottom, when you reached for a way to verify any of this, you found that verification is impossible because every tool you have is made of the same construction you were trying to test. The spiral is closed, 0%, no exit, no way to check, and you are still here. You are still reading, you are still thinking, you are still the only known entity in the entire universe that can ask the question, is any of this real, and keep going regardless of the answer. Think about that for a moment, not as a philosophical exercise, as a fact about you. 14 billion years of cosmic evolution produced a system so sophisticated that it can question its own existence. That system is sitting wherever you are sitting right now. And it works. Not despite the interface, because of it. The sunset you will see tomorrow evening is not real. There is no color in the sky. There are wavelengths and your brain will paint them orange and red and gold because that is what 3.8 billion years of engineering designed it to do. The face of the person you care about most is not what they look like. It is an icon your interface built so that you could find them, recognize them, love them. The music that changed your life was never in the air. It was pressure waves, and your brain turned them into something that made you cry. None of it is real in the way you thought it was. All of it is yours. Every color, every sound, every touch, every moment of beauty your brain ever constructed from raw data that carries no beauty in it, that is not a flaw. That is the most extraordinary thing that has ever happened in the known universe. A cloud of atoms that learned to hallucinate so well that it built science, and art, and love, and meaning from a signal that contains none of those things. You are not the victim of an illusion. You are the author of one. And the illusion is magnificent. Go live in it. It was built for you. Built